Welcome once again to my YouTube channel. Today we are going to continue with the calculation in motion. We have a question on the board under motion. It reads, a body at rest is given an initial uniform acceleration of 8 meters per second squared for 30 seconds, after which the acceleration is reduced to 5 meters per second squared for the next 20 seconds. The body maintains the speed attained for 60 seconds, after which it is brought to rest in 20 seconds. A. Draw the velocity time graph of the motion using the information given above. B. Using the graph, calculate the I. Maximum speed attained during the motion. II. Average retardation as the body is being brought to rest. III. Total distance traveled during the first 50 seconds. IV. Average speed during the same interval as in II. Okay, so we are going to solve this. We have solution to question A. So we are asked to draw the velocity time graph, and as you know, velocity time graph has a slope as acceleration because it's a graph of velocity against time. So on the vertical aspect, you have velocity. On the horizontal axis, you have time. So we have graph of velocity against time. So here we have the velocity measured in meter per second. Then here we have time measured in seconds. So at this point, we have the origin 0, 0. Now, a body at rest is given an initial uniform acceleration of 8 meters per second. You remember, a body at rest will always have what? Initial velocity to be 0. So at rest, we have initial velocity here. So it accelerates uniformly with acceleration of 8 meters per second. So the acceleration is 8 meters per second squared. So it accelerates to a certain point for 30 seconds. So the time taken for the acceleration is 30 seconds. After which the acceleration is reduced to 5 meters per second. So the acceleration was reduced to 5 meters per second. So we have 5 meters per second squared. So the acceleration was reduced in a time 20 seconds. So add 20 to 30 seconds already. You have 50 seconds. The body maintains the speed attained for 60 seconds. So this body maintains this very speed for the next 60 seconds. So we have next 60 seconds. If you add it up to 50 seconds, we are going to have 110. After which it is brought to rest in 20 seconds. So it was brought to rest in 20 seconds. So at this point, the 20 seconds added to 110, it gives what? 130 seconds. That shows the graph of the motion. Now let's get to question B. So solution B, where we have question number I. So we are now asked to find the maximum speed attained during the motion. So the body, this is the velocity now. So when you check each of those points, you will see that the one that is maximum is this. So here is the maximum speed. So in order to get the maximum speed, we have our initial speed, we have our final speed along this path. So we have to write down the parameters. Initial speed, we have u equal to 0 because it is at rest. Then the final speed, which is v, is the maximum velocity. Then the acceleration during this motion is 8 meters per second squared. Then what's the time taken to get to that maximum point? You trace the time, it is 30 seconds. So at this point, we have to look into the formulas we have in motion, we have three equations of motion. Then the first, the second, and the third, based on Isaac Newton. Then check the one that correspond with all these parameters we have. Like we have three equations of motion. The three equations of motion. Please, I will encourage you to go back to the topics I have treated previously in order to master the equations of motion well. Then we have the first one, V equal to U plus AT. We have the second one, S equal to UT plus half AT squared. Then we have the third one, V squared equal to U squared plus 2AS. Then, out of this, we have five parameters. That is, we have V, we have S, we have U, we have T, we have A. Now, these five parameters, if we are to check in each of the formula, you will see that each of the formula is lagging that very what? One parameter. Look at, for this equation 1, there is a parameter that is not there, and that should be what? Distance. It doesn't have distance. Equation 2 do not have V, final velocity. Equation 3 did not have time, which is T. So in order to make the solving easy, to know the very formula you are going to use, check the four parameters and see the one that is lagging, the one that should make it 5, which is not here. We have U, V, A, and the T. So the one we don't have is S. And the one that lacks S is equation 1. That means in order to get the maximum velocity, which is this, we are going to use what? We are going to use equation 1. So using equation 1, so we have V equal to U plus AT. Now, V, maximum velocity, that's the one we are looking for. Initial velocity, we have it to be 0. Then acceleration, we have it to be 8. Then times T, which is 30. So the maximum velocity will now be 0 plus 8 times 30. 8 times 0 is 0. 8 times 3 is 240. So the maximum velocity now becomes 0 plus 240. We have 240 meters per second. Now we've got the maximum velocity. Then the next question there is what? Average retardation as the body is being brought to rest. So solution B, II. So average velocity as the body is being brought to rest. Average retardation. Now we have retardation. Here is retardation, here is retardation, but the one that is retarding to the rest, the one that retards to the rest is this very one. So it's this very one that we are asked to find. So you remember, retardation is a negative acceleration. Now, in order to get this very retardation, we need to know the velocity at this point. Although the velocity at this point is already 0. You trace it to the vertical axis, you have 0. Then what about this? If you trace it to the vertical axis, we know the value. We don't know the value. Now, in order to get this, the velocity here is the same with here. So in order to get it now, we need to get the velocity here, which is equal to the one here. So at this point, we consider this body, a body that decelerates to this point, starts from here. So from here to this very point, we know we need to get the velocity here. Then the velocity at this point is the maximum velocity, which we've got as 240. So having got the velocity here, we need this very one. We have the acceleration, but here, acceleration is 5. Remember, this 5 is what? Is a negative acceleration because the body is retarding. Like I said, retardation is a negative acceleration. Then the time interval here is between 30 and 50. So in order to get this velocity, we write down the parameters here. Decelerating from this point, we have initial velocity to be 240. Then it now decelerates initially from here to this very point. So the final velocity is V. That's the one we are now looking for, okay? So the acceleration, that should be negative acceleration. We have minus 5. meter per second squared. Then the time taken to decelerate from here to here should now be what? The time interval, which is time between 30 and 50, should now be 50 minus 30. We have what? 20 seconds. So the time now is what? Is 20 seconds. Now, which of the formula are we going to use from the three equations given? We have here UVAT. One parameter is missing as well. And that one parameter is what? S, which is the distance. And the one that lacks one parameter, which is S, is equation number 1. That means we are going to use equation number 1 to get final velocity, to get the velocity we are looking for. So at this point, we have V equal to U plus AT. So in order to get the V, we have to do the substitution. U, we have 240 plus A. Our A now is what? Minus 5. Then times T. The T here is what? Is 20. So the velocity now becomes 240 plus minus 5 times 20. We give minus 100. So plus minus, we give minus. So at this point, 240 minus 100, we have what? 140 meter per second. So we've got the velocity at this very point. And that velocity is the same with the velocity. So here we've got what? The velocity now, which is 140 meter per second. Now we can get the retardation. So what will be the retardation in that case? So the retardation, of course, you know, getting the retardation as a negative acceleration, we have to now write down the parameters. So we write down the parameters. Let me solve it the other side. So the retardation, which is the negative acceleration will now be equal to what? So we write down the parameters. We have initial velocity as the body retards from this point to here. Here automatically becomes what? Initial velocity, while here becomes the final velocity. So the initial velocity for the retardation here is 140. So we have U as 140 meter per second. It retards from this very point to this point. So the final velocity here becomes 0. So the final velocity is what? Is 0. Then a body that retards here, the acceleration here becomes what? The acceleration. This is the acceleration. Then we have the time taken from here to here. We have the time interval here. Moving from 110 to 130 seconds. The difference will give you the time interval, which is 130 minus 110 will give us what? 20 seconds. So the time interval from here to this very point is 20 seconds. So we have the time as 20 seconds. Then in order to get acceleration first, the acceleration of the body from up to down there, we get a formula that relates these three parameters. Now we have U, V, A, and T. One parameter is missing here, which is S. And the very formula we are going to use will also be equation 1, because the distance is missing here. So we use equation 1. So we now have what? V equal to U plus AT. Then in order to get this very acceleration, we make A the subject. So we have V minus U, then divided by T equal to A. So this is the formula of acceleration we are going to use. So at that point, we have acceleration, which is V minus U all over T. So A now becomes V is 0 minus U, our U is 140. Then all over time, the time is what? 20 seconds. So A becomes 0 minus 140 gives 140, negative 140, then divided by 20. So if you divide this, we are getting minus 7. So minus 7 meter per second squared becomes the acceleration. So retardation now will be negative acceleration, which will now be what? 7 meter per second squared. So either you write it in this very format that acceleration is minus 7 meter per second, or retardation is what? 7 meter per second. And that summarizes the question number BII. Then we get to question III. We are asked to calculate the total distance traveled during the first 15 seconds. Okay, so during the first 15 seconds, that is moving from 0 to 50 seconds, which means we are interested with the area of this, because distance covered is the area of the surface. So in order to get the area of this, we need to split it to at least to the shape of which we know. So we have this shape. If you split it into two, then here automatically becomes triangle, while here becomes trapezium. Okay, let me just differentiate it as first distance, the second one. So you get the S1, which is the total distance of the triangle, and the second one, total distance of the trapezium. So the distance S1 is the area of a triangle. Area of a triangle, which is half base times height. Then SE2, you get what? Area of a trapezium. The area of a trapezium, which is equal to half sum of parallel sides, the sides that are parallel, sum of parallel sides times height. So the distance totally now becomes SE1 plus SE2. So let's get the SE1 first. So SE1, we have area of triangle, half base times height. Then for this very triangle, then we are going to have the what? The base from 0 to 30. Difference is 30. So the base is 30, while the height is equivalent to this. So the height is what? 240 from here to here. Along the vertical is 240. So we have half base. Our base now is from 0 to 30. Then times the height from here to here is 240. So we simplify this. Half of 30, we give what? We give 15. Then times 240. So we divide this. We multiply 15 by 240. So 15 times 240, we have 3,600. 3,600 meter. So we've got the area of this very triangle. So the next is to get the area of a trapezium. So the area of the trapezium, let's solve it here. So the area of a trapezium, which is S3, area of trapezium is half sum of parallel sides, then times height. Now let's check the side that are parallel. Look at this. This very side is parallel to this side. I hope you can see it. So we have to get the length here plus the length here. So from here to this very point is 240. That is maximum height. The maximum height 240. So we have half of 240 plus, then from here to here, we have this speed as 140. So from this point to this point, we have what? 140. So we have 140, then times height. So the height will now be the distance between the two vertical lines. So the height now becomes 50 minus 30. So 50 minus 30 will give you the length here, which is what? 20. So we have 20. Hence we have half of 240 plus 140. It will give us 380. Then times 20. So if you simplify this, we have half times 380 times 20. I would prefer doing it in this way. Half of 20 will give us 10. So we now have what? 10 times 380. Or 380 times 10, which will give us what? 3008. So we have this as the SE2. So our total distance now becomes SE1 plus SE2. And we've got SE1 as 3006. So the total distance is 3006 plus SE2, which is 3008. So if you add it together, so you punch with me, we have 3006 plus 3008. We have 7,400. So the total distance is 7,400 meters. That has answered the third question, which is II. So lastly, we are to find the average velocity, IV. So average velocity will now be the total distance all over the total time. That's the time interval for that very distance covered. And we've seen that the total distance is 7,400. So we have the total distance, 7,400, divided by the time interval. Moving from here to this very point, the time interval is 50. So divided by 50. So if you punch your calculator, we have 740 divided by 50. Then we are going to get 1,148 meter per second. And that gives the average velocity. So with this, I believe I have simplified this very exercise. Do well to subscribe, share for others to learn. See you on the next class.